Today on How It's Made. Pewter flasks. Perfectly portable, they are the ultimate hip accessory. Potato salad. Who thought cold potatoes and mayonnaise could be such a hit? Hydrogen fuel cells. Trust me, the facts on this are a gas. And engineered wood siding. I promise you won't get bored with this one. But first... Long before we all carried plastic water bottles, there was the hip flask. It was carried and concealed in a pocket. But unlike the water bottle or the earlier canteen, the flask was used for carrying a very different kind of refreshment. Lashings of your favourite tipple. In the early 18th century, the sophisticated and well-to-do carried elegant flasks crafted from silver or pewter. But in today's world, flasks are generally given as gifts, typically engraved with monograms or messages. Pewter is an ideal metal for flask making because it's so malleable. The manufacturing begins with a sheet of raw pewter that's about 2 millimeters thick. A guillotine cutter slices a rectangular starting piece, which is called a blank. The blank is laid onto a copper plate, which has the flask's decorations on it in raised form. The plate and blank then go through a rolling press, and the compression stamps the design into the malleable pewter. The decorated blank goes into a hydraulic press, fitted with forming guys, and in a single strike, the blank is shaped into half a flask. A trim press clips off the excess pewter around the perimeter. Repeating the entire process produces the other half of the flask, and the two parts are soldered together. Some flasks are styled manually. A metalsmith heats the blank with a gas torch to make the pewter pliable, and then wraps it around a flask-shaped aluminium block. He hammers the adjoining edges flat with a wooden mallet, and fuses the edges by running a line of pure tin solder down the entire length of the joint. On another press, workers stamp out pewter sheet rectangles which will complete the flask's shape. The metalsmith solders one rectangle to the top of the flask, then cuts it to the right shape. A pewter thread is then added to make the cap. Before fusing another rectangle to the bottom of the flask, the worker stamps it with the maker's mark and dabs the bottom of the flask in flux. Flux is a chemical which helps solder run smoothly without globs. The bottom is then soldered to the flask and the craftsman contours it. Next, he puts a drill through the cap thread and bores a hole for filling. Then, with an abrasive belt, he grinds all the solder seams flat, making them barely visible. The finished flasks are filled with water to check for leaks and clean the interior. Pewter caps are then screwed on. Now a buffer takes over. With a cloth wheel and pumice, he removes any little imperfections from the surface. Once the buffing's complete, the flasks go through a wash cycle to clean off pumice residue. Now the finishing touch. A polisher shines up the pewter until it has a reflective mirror finish. flask is then emptied of any water that's still left inside, readying it for its new role. No longer concealed under clothing ready for a crafty sip of something, these modern-day pewter flasks are meant to be seen and treasured. Potato salad is much loved the world over. Whether at a buffet or a barbecue, it's a delicious addition to the menu. But when you're busy sweating over the burgers, there may not always be time to whip up your own special recipe. Then it's time to go from homemade to ready-made, fresh from the factory. The appeal of potato salad is massive. People from around the globe have made a variety of recipes through the years. In fact, there are so many different recipes, you could dedicate an entire cookbook to this king of dishes. But no matter how you have your spuds, potato salad always has that special appeal. Naturally, it's all about the potato. In this factory, they use varieties with low water content, so the potato salad doesn't end up soggy. Fresh from the field, they gently funnel out of the trailer onto a conveyor belt and head up to a washer to clean off the dirt and remove the stones and pebbles. The potatoes then bounce across rollers covered with a fine grit abrasive, and this scrapes off the skins. Once peeled, they're inspected for bruises or other flaws. Then it's down a chute towards the dicing machine. It's equipped with these cutting cylinders. The blades are positioned vertically on one and horizontally on another. They revolve in sync and carve the potatoes into cubes. The blades can be adjusted to cut the cubes larger or smaller, depending on the recipe. Here they're cutting out medium chunks for an American-style potato salad. Trays full of potato cubes enter into a big pressure cooker to steam cook for 6 to 10 minutes. Pressure cooking best preserves the nutrients and original flavour of the potatoes. While the potatoes are cooking, they prepare the crunch in your munch, the celery. The celery sticks first go through a cleansing solution to scrub them clean. On the way, an inspector sorts out leaves and overripe pieces. This time, the cutting cylinders are set to dice more finely than with the potatoes. Out of the washer and thoroughly rinsed, the celery sticks fall into the dicer and it chops them into small bits. The minced celery exits into a vibrating trough and is agitated in a peroxide solution. The extra wash is a safety measure as the celery won't be cooked and cooking kills bacteria. After a further rinse, the soaked celery lands in a perforated drum that slides into another drum. The colander rotates within the drum to spin dry the celery. The next ingredient is eggs. They arrive at the factory already hard-boiled and de-shelled by the supplier, so all that's left is the slicing and dicing. The egg whites cube nicely. The yolks separate and crumble completely. With so many yolk crumbs, their flavour will permeate the entire potato salad. They're now ready to combine some of the ingredients. Finely cut onions are added to the egg, followed by diced red pepper and then the celery. They weigh the mix with each new ingredient to confirm that the portions are correct. Now for the dressing. They pump the ingredients out of large storage tanks. They include vegetable oil, sugar, vinegar and egg yolks. Whipped into a frothy mayonnaise, the dressing flows into a steel mixing vat. The chopped eggs and vegetables are then added, followed by the cooked potatoes, the final ingredient. Blades spiral slowly for a gentle mixing to stop the potato salad turning to mush. With the salad now ready to go, suctioning devices set plastic tubs on a track conveyor. Sensors signal the tub's approach to dispenser nozzles, and they stop right on cue. A portion of salad is then piped into the tub. Suctioning arms then flip the lids onto the tubs, and they're sealed and ready to go. Even without their jackets, these potatoes are welcome anywhere. Coming up, we pay a visit to a splinter group. Well, it's the factory where engineered wood sidings are made. And we have a science lesson to go to. But don't worry, this one's interesting. Turning humble hydrogen into electrical power. We see how fuel cells are made. Join us after the break. Hydrogen fuel cells run vehicles and other machines by directly converting the chemical energy in hydrogen gas into electrical power. Hydrogen is an abundant fuel source, and it can be extracted from water, enabling almost any country to produce it domestically. Hydrogen fuel cell engines can power vehicles or run backup generators for large computer operations. They produce electrical power without any emissions. At the heart of the engine is a stack of super-thin hydrogen fuel cells. The engine's blower pushes in air. The fuel tank then feeds in the hydrogen gas. Hydrogen and oxygen react to create electricity. Each fuel cell is made of 5 parts. On each end, there's a channeled plate, made primarily of carbon, a material which conducts electricity. Hydrogen enters the cell through the first plate, which channels it through the next component, a chemically treated paper, which conducts both gas and electricity. Then the hydrogen enters this membrane, where it splits into protons and electrons. The protons react with the oxygen, producing water. The water passes through another paper to the cell's outer plate, where a pump draws it away. Meanwhile, the electrons travel to the end of the stack of fuel cells to electrical wires. After assembling the stack, technicians compress the fuel cells in a hydraulic press. Compression helps the current flow smoothly from cell to cell. It also presses the rubber gasket around each plate to the adjacent one, sealing the stack so the hydrogen can't leak out. The technicians run a quality control test with nitrogen gas to verify the seal. Before releasing the press, they install high-strength steel rods to bind the compressed cells together. For a stack this size, the rods apply 3 tons of pressure. With the stack now off the press, they hook up an electrical circuit board, which monitors the voltage of each fuel cell. After securing the connectors to the stack with an adhesive strip, it's just a matter of connecting one to each fuel cell. They secure that connection with a special type of epoxy, which contains silver to conduct electricity. They then mount the circuit board and a plastic cover to protect it. The fuel cell stack is now fully assembled and moves on for testing. The technician mounts it on a test station and connects a hydrogen line, an air line, and a water line for cooling. The testing machine runs a 3-hour automated performance test. Technicians mount the stack onto the engine's structural frame and then install the hydrogen recirculation pump. A water pump is then fitted, which cools the fuel cell by pumping in cool water. They then install the components which supply the hydrogen, stored at high pressure in the fuel tank. And it's that pressure that pushes the gas through the stainless steel fuel lines to the cell. Then the fan that blows outside air into the fuel cell to react with the hydrogen. This filter removes dust and other contaminants drawn in from that fan into the fuel. In the meantime, technicians have assembled the computer that controls the whole engine. They connect the wires from the fan, the pumps and the other engine components to the computer. They connect the fuel cell output wiring, which are the wires that carry the current the fuel cell creates and sends it to whatever vehicle or device the engine is powering. A tiny portion of the cell's output powers the pumps and other engine components. Now fully assembled, the engine undergoes extensive performance and safety testing. Once it passes every test, technicians perform a final visual inspection and then install the sheet metal cover. The hydrogen fuel cell engine is now ready to be delivered to the customer, and installed in the machine it'll be powering. Whether running a vehicle like this forklift or powering computer servers, the only byproduct is waste heat and water, which is why hydrogen power is clean energy. It's that simple. More power to you, I say. Engineered wood siding is just clapboard reinvented. With its rough grain, it resembles natural wood. But these boards contain strands of wood that are resin bonded for strength and durability, and they're also treated to resist rot and termites. You could say it's jolly good wood. Engineered wood siding is literally a chip off the old block. Lots of chips for that matter. But how do they transform wood chips into a solid piece of wood? It all starts with aspen and other kinds of wood. They transfer the logs to ponds to maintain a consistent moisture content and temperature until production. The logs travel on a conveyor where grooved rollers feed them into a debarker. It shaves off both the tree bark and the cambium, which is the soft green layer beneath, and this exposes the white aspen wood. Circular saws now cut the logs into smaller chunks, which are known as bolts. The bolts now meet a machine called the waferizer, a 9-ton steel disc that holds 48 razor-sharp knives. When this disc spins, the knives slice the bolts into wafer-thin chips, known as strands, in just seconds. The strands are the same length, but slightly different widths. They remain flat and don't curl up, thanks to the stability of the aspen wood itself. A conveyor delivers the wood strands to large steel bins, and from here, they're fed at a controlled rate to a dryer 1 floor below. Heated by a furnace, this cylindrical dryer rotates to tumble dry the aspen strands. A blender then coats the strands with resin adhesive, wax for moisture resistance, and a preservative to ward off rot and termites. A release agent is sprayed onto the next conveyor to prevent the strands from sticking to it. The first layer is put down so the strands all land in the same direction. The next falls in a more random configuration, and the third layer is again uniform and parallel. Layering the strands will provide dimensional stability in the finished boards, and the result is a loosely interwoven mat of wood. A carriage now moves a large circular saw back and forth to cut the mat into sections, approximately 5 meters in length. A steel carriage stretches a sheet of heavy industrial-grade paper across the mat strands. The paper's been coated with a primer and saturated with a durable adhesive that bonds with the wood strands. A multi-tiered press closes to both compact the mats and bake them. The heat and residual moisture activate the resins to turn wood strands and paper into one solid piece of engineered wood. The press opens to reveal the cured and compacted composite sheets. The thickness has gone from roughly 10 centimeters to just under 1 centimeter. This conveyor also doubles as a scale to confirm the content of each sheet is exact. Saws trim the sides and slice the sheet in two. The sheets then get pushed forward and another saw trims both the ends. No waste wood here. The trimmings are ground up and used as fuel for the dryer. They now have a stack of 40 engineered wood sheets that are ready to be turned into siding boards. The boards are pushed one at a time into saws that slice them to the correct dimensions. Now cut to strips, they exit in a cluster and then separate. A paint gun coats the trimmed edges with primer, and this seals any exposed wood from the elements. After a trip through the oven to dry the primer, they head towards an inspection station where they're checked for blemishes or damage. If any is found, the board is rejected. Following production, the siding is painted to the customer's exact requirements, and then it's off to its new home, which, as it happens, is on the side of someone else's.